The research I hope to do during my PhD is on orbit determination and planetary science. And this basically means taking data from spacecraft that are orbiting moons and planets, or even just moving in space, and using that data to reconstruct their trajectory or their orbits. And that is why it's called orbit determination. And in the process, you also obtain data on the forces that influence the orbit and the trajectory of this satellite. And those forces come always from planets, from the moons, from everything that is around in space. And with that data, with that information that you get about these bodies, then you can reconstruct what they are like in the inside, what their shape is, how they deform. And that allows you to build a bit of a natural history of the bodies themselves and together of the solar system and of us as planet Earth. Now, in this process, there is what I will do will be focused on the math that is used to process this data. There is two challenges right now. One of them is related to combining very old data, which usually spans bigger time, so that is good because we have more data points spread in time, but it's lower quality. And newer data, which is shorter, but way better, with much higher quality. Mixing these two and processing them together is not easy. It's a challenge, and that is one of the topics that I will hope to cover. The other one is the algorithm naturally gives you also error bars for your results. These error bars, because of how the algorithm is built, they are smaller the more data you have, which is expected. But at some point, this uncertainty that the algorithm gives you sort of falls a bit below the uncertainty that you would expect, in the sense that in doing the processing of the data, there is the uncertainty of the observations. They have errors, it's life. But the processing itself, you need to involve modeling also the accelerations of the bodies to be able to properly interpret the data, basically. And in this modeling, there is also errors, there is mistakes, there is simplifications. In the end, physics is super complex, and in space there is a lot of things, and you cannot put all of them into your processing. So you simplify a bit. And we are right now at the point at which we have good enough data and enough amount of data that our uncertainties, for some cases, fall a bit underneath what we would expect. And that is something whose solution is not trivial, and which is also something I would hopefully work on during the PhD.